Thank you, everybody, for joining us for this next phase of the workshop, which is a really nice treat. We've got a great collection of panelists who have agreed to join us and talk about our topic, which is advantages and disadvantages of rule-based approaches in the neural era. And what's particularly nice about the panel that we have been fortunate enough to collect here is that we've got representatives and expertise from quite I think, a good span of different backgrounds, experiences, and so forth. In particular, we've got lots of representation of academia as well as industry, and also folks that have been involved for a long time in evaluation of NLP systems. And also we're fortunate to have a DARPA program manager with us who not only has to make decisions about what sort of technology is being used, but for shaping large-scale research that at least the Defense Department is interested in. So I think Ellen's talk at the very beginning of the workshop really did a nice job of setting the stage for a whole bunch of the topics that we could get into. I think at this point, let's first introduce ourselves. And then what I'll do is I'll review, again, the rules of engagement, how we plan to run the panel discussion, and then we'll get into it. So I'll start off by introducing myself. I'm Clay Morrison. I am an associate professor here at the School of Information at University of Arizona. I wouldn't consider myself a sort of NLP person. I'm more of somebody who does AI and machine learning, but I have a lot of applications in NLP, and I work with a lot of NLP researchers. But rule-based systems and working with representations with structure has been something that I've been deeply cared about for a long time. Let's now turn over and have Mihai get a chance to introduce yourself.
Hi, my name is Mihai Surdeanu, and I've been working on NLP for 20-some years. And most recently, I am very interested in explainable methods for NLP, hence my interest and involvement in this workshop.
Good. And now what I'll do is I'll go through our panelists, and I'll call you out by name, and please give a brief introduction. Let's start with Ben Gyori.
Hi, my name is Ben Gyori, and I work as a research fellow at Harvard Medical School. And I originally studied computer science, but for my PhD, I started working on systems biology, and my expertise is actually in modeling complex systems with a focus on biology. And so over the past few years, I've been really interested in using scientific knowledge and gathering and assembling scientific knowledge to automatically derive models of complex systems or help humans model complex systems. And so NLP is really important in that effort because of all the scientific publications that are constantly being produced and that have to be somehow captured systematically. And also for various forms of human-machine interaction through dialogue, for instance. And so I've been a user of NLP systems and also a collaborator in developing NLP systems. I've worked on the integration of, I think, about 15 or 16 different NLP systems in various DARPA projects. I'm actually really interested in how multiple systems can be combined with different strengths and weaknesses. And so, and I've also taken part in, systematic curation of various systems, their deployment, how difficult it is to make them work in applications. Yeah, that's about it.
Thank you, Ben. Next, Ellen, can you reintroduce yourself for those who are joining us now for the panel?
Sure. Yeah. So I'm Ellen Riloff. I'm a professor in the School of Computing at the University of Utah. And I have a wide range of interests. I'm interested in information extraction, affective text analysis, semantics, and narrative story understanding, deeper understanding. And I do a lot of work, as some of you may know now, on bootstrap learning for NLP.
Great, thank you, Ellen. Next, Dayne, can you introduce yourself?
Sure, I'm Dayne. I am a program director in the Artificial Intelligence Center at SRI. I lead a small group of scientists in San Diego, the Advanced Analytics Group, and I've been working on kind of problems of NLP for 2.5 decades with a strong focus on information extraction, but also considerable focus on scientific documents. I'm currently playing hooky from the scholarly document processing workshop, of which I'm a co-organizer. As my talk suggested, I started my career kind of focusing almost exclusively on machine learning applied to NLP and information extraction, but have recently moved increasingly into kind of rule-based methods to deal with some of the cumbersome aspects of machine learning.
Great, thank you, Dayne. Next, Laura, can you introduce yourself?
Hi everyone, I'm Laura Chiticariu, and I am in IBM. I'm the chief architect for all IBM language offerings. I'm in the product organization now. I have spent all my career in IBM after I finished my PhD in using factors, which had nothing to do with NLP. That means I have essentially learned NLP from the ground up in an industry setting. I spent the first about 9 years of my career in a research and development role, writing lots of papers and developing a rule-based system for information extraction called System D, which made its way into more than 20 IBM products since then. And at some point in 2017, I made the move to the product organization. So I'm now in the AI and automation software division in IBM, where I oversee the language strategy. And for the past 5 years, and even before that, I have spoken with lots of customers using or needing to use NLP technology. So I will speak here from the industry perspective.
Great, thank you, Laura. There was quite a bit of echo on your audio. Am I creating echo as I speak? If not,
Not that I hear.
Yeah, it sounds like it might be on your end, Laura. It's getting like a double. It's like you have 2 mics possibly live, if that's possible.
Is it better now?
It's still, yeah, we can still hear the echo.
How about now?
Yeah, it's, one possibility might be to try logging out and then logging back in and seeing if that helps.
Yeah, I'm trying to play here with my microphone. Can you hear me better now?
It's still double echo. I don't know if it's possible that it's simultaneously using your computer mic and then like another mic.
Better now?
No, it's still, sorry, it's still echoing. Are you still there? Okay.
Yeah, I'm still here.
Yeah, it might.
You're still hearing back.
Yeah, it's definitely still echoing. It might be good to try logging out and then logging back in.
Okay, yeah, let me do that.
Okay, good. Thank you. Next, let's have Lynette. Could you introduce yourself?
Yes. Hi, I am Lynette Hirshman. I am at MITRE, where I'm a technical fellow. I have, I'm going to date myself here, which is fine. I've been doing this for a very, very long time. I started out, I got my PhD at University of Pennsylvania in formal linguistics. And one of the people who was there at the time was Zelig Harris. So I have a very strong affinity for structural linguistics, empirical methods of natural language processing, and really completely resonate with all the with Ellen's talk and Dayne's talk earlier. I made a brief stop, not a brief stop. I was at the Linguistic String Project, which had the where I collaborated extensively with Ralph Hirshman and Naomi Sager and Carol Friedman, who may be names familiar to you. And we worked on a very large computer grammar of English. I then went to Unisys, Burroughs, SDC in some order. It was all the same company that kept changing its name, trying to find its identity, where I worked on logic programming, another rule-based framework. From there, I went to MIT and worked in the spoken language systems group, where I got a heavy exposure to statistical methods that were being used in speech, and worked on spoken language understanding there. And then I ended up at MITRE, which is where I've been since 1993, so almost 30 years now, where I eventually gravitated to working in biomedical informatics and focused a lot on evaluation, partly because I also spent a lot of time working with DARPA on various programs. And so that has heavily influenced my perspective. I really resonated with what Dayne was talking about in terms of, and I think Ellen talked about this as well, the small scale applications. You have somebody comes to you, we call them sponsors as opposed to clients, but somebody comes to you with a problem that's a kind of niche problem. They don't have the task very well defined. They don't have any data, and it's very hard to get subject matter expertise, and they want you to build them a system that does something useful for them. And so those are the kinds of applications I've seen a fair amount of. And so in the interest of evaluation, I'm really very interested in exploring how we can use things like challenge evaluations, which I've been heavily involved in terms of, for example, biocreative for the biology community, how we can use these kinds of challenge evaluations to focus on things other than F measure. So I'll leave it there and hope we'll get into that in the discussion. So thank you. That's it.
Great. Thank you, Lynette. And Joshua, can you introduce yourself?
Yeah, hi, Joshua Elliot. So I'm a program manager in the Information Innovation Office at DARPA. You'll have to excuse me. I am, as many of you know, I'm a morning person, and this is way past my bedtime, so I'm already half asleep while I'm sitting here. But if Clay considers himself an outsider on this panel of NLP people, then I'm literally on the moon. So I'm a reformed physicist who somehow found their way to running programs at DARPA and stumbled into trying to be what Lynette nicely referred to as a person that's trying to get a person that's trying to get nice things out of NLP in order to solve actual real problems. And I've found along the way that it's incredibly difficult to do that, to get those solutions out of NLP that you need. And oftentimes, in fact, in my experience, more often than not, the rule-based language systems actually get those solutions to you either better or faster or both. And so I've been not a reluctant convert, but a convert all the same to this field of view. So happy to be here, excited for this conversation, and excited to be on this panel of illustrious people, of whom I know most of. So thank you.
Yeah, great, thank you, Joshua. And it's definitely that outsider perspective that's actually quite valuable. Laura, let's try again and see if the mic. Now you're very quiet.
Oh,
It sounds like your microphone is very far away. Do you happen to have a headset, maybe?
I do have a headset.
Oh, okay.
I had a headset even before, a different one.
Yeah. Okay. Definitely the echo is gone. It's just, yeah, maybe just making sure that the microphone is very close to your mouth, maybe. Oh. It's starting to get closer.
Louder now?
That's better. Yeah, that's starting to sound better. Okay, good. Now that we've had a chance to have the panel introduce themselves, I wanted to just review quickly some rules that Mihai and I came up with how we would like to conduct the panel discussion. First off, I think again, because we're all, we're largely running this virtually. I know that there's a large component of folks that are in person, but all of our panel is online. For that reason, Mihai and I will ask all of the questions. And we do ask that the audience, please do type your questions into the chat window for Zoom. If you are in person and are not able to log in, please try to coordinate with Becky Sharp and Marco Valenzuela, who are there, and they can help get your question on. We've got a collection of questions that we came up with ahead of time, in part as we were thinking about shaping who we invited to be on this panel and the kinds of topics that we think would be very stimulating. But we very much would like to have the audience be able to participate and ask questions. So we won't necessarily ask all questions from the audience. We're going to do some selectivity, but I think that we've got lots of opportunity for some great discussion here. Finally, we just ask that you please stay muted and not interrupt the speakers when they're speaking. One difference is that for the panel, all of you should feel free to be able to step in and make comments. We want there to be lots of opportunity for exchange and follow-on points, etc. So with all of that said, let's get into this. And what I'll do is I'll start with a question that Mihai and I came up with. Actually, I shouldn't say Mihai and I, it was actually a collection of us, the organizers. And some of these questions that we're going to be asking actually come in clusters. There's sort of related variations and so forth. So we're going to start with the first question being, it's more of a historical question. We thought it would be good for sort of setting the stage. And the question is, what counts as a rule-based system for natural language processing? And Mihai and I were particularly thinking of Lynette and Dayne, who have been working for quite some time in the field of NLP, working with rule-based systems as well as statistical-based systems. Of course, basically everybody on the panel, Ellen as well, although you got to give us a very nice introduction to your work in the first hour. So let me pose this question to Lynette and Dayne, and then open it up to everybody.
All right, I'll jump in, and I'm sure
Great.
Dayne can provide lots of more concrete examples. But I mean, to me, a rule-based system, I think Ellen described quite a range of rule-based systems. But I would go back to, the linguistic string project grammar, where we were trying to write a, large-scale computer grammar of English using, explicitly syntactic rules. And, and everything beyond that. I mean, maybe Dayne has some more specifics that he can pull in.
Well, I don't know about specifics, and I'm not sure how this is a historical question, but I mean, if I think about what I would call a rule-based system, say if I were reviewing a paper, it would be a system that has some sort of declarative syntax with discrete interpretation semantics, and as opposed to either a machine learning system, which is kind of strongly data driven, or something in code, which I would call heuristic or algorithmic. So I think a rule-based system typically means a system that's implemented in a somewhat more inspectable fashion than the alternatives.
Yeah, Dayne, I think you had a nice description of it as a symbolic system. I mean, that. But
yeah, I mean, I would consider that roughly synonymous with rule-based, although rule-based typically entails certain interpretation semantics.
Yeah. Does anybody have anything that they think should be added to that, those descriptions, or does that feel pretty?
Yeah, so I think that's a great definition. Yeah. I would add that the rule-based system probably has a rule language. That language has to be defined somehow. It has some expressivity, as opposed to just writing Python code or Java code, right? Which is a Turing complete language in which you can express practically anything you may want, but you need some sort of declarative. Some people would say declarative, others have said declarative a long time ago, but it wasn't really declarative as in the true sense of declarative, which means explain what you want the system to output as opposed to how the system will output it. And beyond the rule language, you probably need a data model, because the expressivity of the rule language has to be defined in terms of the data model and the operations that are possible on the data model. So for text, usually the data model will contain some notion of a span or a range, which is a sequence of characters in the input text. And then you define the operations that are done on spans, like does this span contain this other span? And then, of course, you define the primitives in your system, which would be very simple things like regular expressions or dictionaries. And then could be more complex things like maybe the result of a syntactic parser or the result of a semantic parser. And these together with the operations will give you a lot of expressivity in what kind of rules you can define.
That's great. By the way, your audio now sounds wonderful. So
awesome. So glad.
Yeah. The work paid off. But actually, I think you were raising some really good points there, which is something that I think, at least I tend to kind of just take as an assumption, but the idea that there's abstractive power to these rules and likely levels of representation, not just specifically about the concrete data, whatever the words, the syntactic patterns, but you can have a hierarchy of potential structure.
Yeah, so I have seen very sequential types of rules, as in is the word Laura followed by the word Chiticariu, but raising the level of abstraction is this word, the noun phrase being preceded by the verb, and then rules on the syntactic parse, right, dependency parse, or rules leveraging the semantic parse of a sentence. And I think the more we raise the level to semantic, the smaller the number of rules you really need to express one thing, right? Which is great, right? Because everybody complains rules are difficult to write. So the more you raise the level of abstraction, the easier they become to write. But that also means you have to have very good, strong primitives, accurate primitives in your system.
Good. I'm going to take this opportunity to now bring in another question that's coming from Gus Han Powell. He asks, how about decision functions involving fuzzy things, for example, an embedding space? Would that be something that could be part of a rule, or is there a boundary? Speak to how that might play into these distinctions that we've been making.
That's a very interesting thing that it's something that I have been thinking about lately. I think once you get into embedding space, rules become a little bit more difficult to reason about because, you know, just let me give you a simple example, right? A dictionary is a fixed set of terms, right? You can say, okay, I'm going to extract all the matches of this dictionary, and then you know when you're going to get an answer, why you got that answer. Once you get an embedding over there, it suddenly starts becoming more probabilistic and more difficult to explain. But I think getting a primitive in the system that says, okay, here are 3 dictionary terms, find matches of these, maybe similar to this thing in an embedding space would save us the work of figuring out an exhaustive set of terms, to the expense of maybe now the rules are more fuzzy because sometimes you may get one match of that dictionary that is kind of iffy, but it matches in the embedding space, but maybe it's not quite what you wanted in your rules. But I'm not aware of work that has tried this, but I think this would be a great kind of primitive that you can have in a system, right? More fuzzy dictionary match semantics.
So I think, as I mentioned in my talk, we've actually implemented this. So in the valid rule language, we have a class of rules that match individual tokens. And one of those is what we call the radius test, and you simply specify a set of seed words and you specify a radius, and then it uses an internal embedding space to decide which words then match within that radius of the set of example terms. And yeah, it's exactly as you said, Laura, it becomes less inspectable. You have, you don't know in advance what's going to match. So it becomes kind of more of a groping type of activity where, you get a lot of false positives, and then you need to kind of carve exceptions out. So it's a double-edged sword, certainly.
Yeah, but definitely interesting kind of primitive to have. And I think depending on the expressivity of the rule language, you may be able to then prune out matches based on other kinds of rules. For example, if you have negation or filtering in your rule language, then you can use this fuzzy matching for your candidate generation rules and maybe prune back invalid candidates with some post-processing kind of rule.
Yeah, there is some recent work in this space from Yoav Goldberg and AI2 in Israel. I think they call it neural search. And there's another recent paper, something with soft rules, and I'm sorry, I'm blanking on the author. So, the field is beginning to experiment with this combination of neural methods and rules. And you guys are right that this is all about sort of where is the balance between precision, recall, and explainability. And we'll get to those measures in a minute. And Dayne, you mentioned a few minutes ago in your talk the idea of tighter coupling of searching this embedding space and bringing that into rules. This is actually related to sort of more historical algorithms. So Michael Collins called it cautious bootstrapping in the 90s, right? And so it's not the particular new idea, but the idea of bringing it into the neural space is novel. And I don't think we understand very well how to combine things.
Great. This is one thing that strikes me is that it seems that the core common theme to rules is discretization of some kind, making a discrete decision, but it's also one that is interpretable. So you can make discrete boundaries, but those aren't always interpretable. In this case, it feels like rules, they're always, or at least if they're going to be useful rules in some sense, rules that we're happier with. There needs to be a connection to interpretation.
Yeah, then I like the point of discretization, because if there's a sort of high-level debate in the field that language is discrete and sparse, so why are we modeling it with continuous models, right? So there is a mismatch there between what the language is and how we're modeling it. We know what we're doing it because we need gradient descent, or as Alan called it, gradient student descent. Which is much easier to do in a continuous space. But there is definitely this disconnect there, and you could easily argue that rules are closer to language because of this.
Yeah, I think it's also maybe worth separating out a little bit the issue of interpretability. That I completely agree. That's often one of the goals of rule-based systems, and it's a very worthy, important goal. But lots of rule-based systems, I think, can also be pretty not so easy to interpret. As soon as you start having weights on some of the rules and rules combined to make decisions, it can be hard to figure things out. And also this issue of fuzzy reasoning, embeddings are obviously highly fuzzy, but even some old rules would use like edit distance against dictionary items. And you don't know exactly what you're getting with those matches either, or any sort of degree of partial match, which is often a common thing. So anyway, I just want to kind of raise that point that if interpretability is the goal, that is something that has to be kept in mind, I think, when designing your rule-based system too.
Yeah, I wanted to go back to the notion of symbolic systems, because I think one of the things that really distinguishes, for me, a rule-based system from a lot of the machine learning-based systems is it talks about linguistic constructs. I mean, the things that are symbolized are linguistic constructs. I mean, they don't have to be, but they are often, and I think that's part of what gives it some better interpretability and debuggability.
I mean, I think, as Ellen suggested, it's really easy to create opaque rule sets. I mean, if you try to do everything from the ground up for a difficult modeling problem with rules, you can end up with a forest that can be quite difficult to understand. And if you ever try to use machine learning to generate rules, you can create some monstrosities that are just very difficult to understand. So for me, I mean, interpretability is less of an asset than what I might call pliability, right? They're easier, rule-based systems are just easier to intervene in. And so a rule-based framework with a UI is a pretty powerful thing and gets you there pretty quickly. And for me, that's kind of the most compelling aspect of the modeling methodology.
At this point, I feel that the metal is hot to jump to a topic that we had discussed ahead of time in preparation that actually involves two sides that are very closely related. One of them is evaluation. How do we evaluate these NLP systems that we're building? And very closely related to that is how effective those systems are in these tasks. And the reason why I want to get to this now, as we're kind of halfway through the panel, is to be able to draw in Joshua and Lynette, who kind of hold some interesting perspectives of both sides of these two topics. You know, in the case of Joshua, helping design and lead large-scale research, a lot of which does depend on NLP systems. And again, as you know, a confessed outsider, how does he make his decisions about what are we going to trust and how do we evaluate these things in these programs? And Lynette's experience, as well as, again, many other people on the panel. So anyway, I wanted to broach both of those topics. Maybe let's start with, since I think we can get a lot into the evaluation side, I want to start with how we're thinking about, well, I guess it does come down to evaluation. When you're making a decision, Joshua, about how well an approach might be, or what approach to choose out of you know, deep learning versus rule-based, sort of what is your perspective of how to approach that?
Yeah, I was tempted to jump in the earlier conversation and yell, like, I don't really care about interpretability if it's still useless, but because it's really, I mean, usefulness and usability is not necessarily synonymous with you know, any of these other terms, whether it's interpretability or any other synonym for, you know, relatively more aligned with the way that we're used to thinking in human terms about language and about sentence structure and about syntax and semantics. It can still be, as Dayne or many other people pointed out, it can still be completely uselessly uninterpretable, even if it's based on rules. For me, for evaluation purposes, it's always been about usefulness, and to be honest, over the course of my time at DARPA over the last 5 years, that's what's caused me to, I think, drift much more towards rule-based approaches, simply because of those evaluation issues. I mean, honestly, I've read probably 200 pages worth of NLP evaluations that Lynette has produced out of MITRE for various different ones of my programs. And, along the way, I've learned that I think the term that I liked to use for the longest time was, what was it? Practical NLP, I think, was the term. I used to tell this to my leadership all the time. They would say, like, you're still investing in NLP, really? Like, haven't we already solved that problem? Or isn't there another program that's doing that? Do you really need that much money to spend on NLP in this program that's not an NLP program? And I would say, well, no, we're not investing. We're not trying to like push the boundary of NLP. We're trying to like create practical NLP, which is a thing that apparently no one has, cracked in the last, couple of decades of working on it. But no, and that's where, again, rule-based systems. And I mean, I thought, was it Laura talking about having to, trying to move towards the not just the semantics of text, but moving to the higher level abstractions of the structures of how people express themselves, especially in expert text and scientific texts, and trying to understand, not just the syntax of sentences, but the structures of how people express knowledge and how people express expert and important and interesting things in text, in complex ways, at multiple levels of abstraction, at multiple levels of different types of syntax. I mean, that's where these things can become really useful if you use them in a practical way. Oftentimes, the challenge is that boundary between the user, whoever the user might be, the expert that we quote unquote, and the actual technology itself. And those interfaces are not good enough, and I'm not sure they ever will be, but they're absolutely not good enough now. And creating these rules or even defining them or understanding them is not good enough now. So explainability is not good enough if it's still not understandable, if it's still not usable, and if it's still not useful to a person who hasn't spent the last 40 years studying rule-based NLP and symbolic systems.
Yeah, I always thought, and I haven't taken any action, but I always thought to draw a parallel between NLP and relational database systems. So in relational database systems, there was Edward Codd back in the 70s, and he invented the relational data model, and then he invented the relational algebra, and then people built the SQL query language on top of it. And relational databases just took off because you had the standard data model and the standard query language. And so people built systems around it, and you could experiment with new methods to do query optimization and new expressivity in the language, adding additional primitives. But there were standard systems where these things could be implemented and experimented with. I think we're lacking something like this in NLP for rule-based systems. We have standard deep learning platforms like PyTorch and TensorFlow. We don't have a rule-based system that is standard with a standard data model and query language where people can do experiments very easily. Because all of you who want to do research in NLP have to build your own rule-based model with your own little data model that doesn't talk to my data model or somebody else's data model. And so we're all kind of wasting a lot of time on these basics. So
Actually,
I don't know,
like,
maybe it's a call for the industry and academia to come up with a standard data model and the rule language for NLP.
I'd like to, on exactly this point, I'd like to draw in Ben Gyori, who is to some extent, in some ways, attempting to do this kind of thing. I'm thinking in terms of like the Indra system that they developed during the World Modelers program, where here the idea was to take a whole collection of machine readers and to try to take the outputs of those and aggregate that into a structured knowledge base. Anyway, I shouldn't be describing. I should give Ben a chance to speak to.
Yeah, no,
to Laura's
indeed.
point.
I worked quite a bit on trying to figure out how to find a joint representation for very diverse reading systems. But the important point there is that I did this with an application in mind, right? For a specific application in mind, which for one set of projects is describing mechanisms in biology, causal mechanisms, especially in other applications, you know, causal assertions in different domains. But the representation at that integration level is very much motivated by a specific set of applications in mind. So it's not meant to be a general NLP integration layer in that sense. It's a little bit different from what Laura alluded to. One point I wanted to make to the prior discussion is that you know, we can definitely talk about rule-based and machine learned systems that are at their core driven by these kinds of approaches, but very often in practice, a kind of integrated system that you encounter contains mixtures of both typically. So all the rule-based systems I've used had machine learned components, and every system that at its core is perhaps built on a deep learning model will have tons of surrounding logic to add additional you know, layers beyond just the machine learned core model. And rule-based systems end up implementing a bunch of things in code to surround the rule logic. So, you know, from various forms of prioritization, handling corner cases, and all those kinds of things are typically at the end of the day implemented in code, not cleanly in the rule language.
Yeah.
Hey,
go
ahead.
Go ahead. No, please go ahead.
Well, I feel tempted to inject a note of friction here because this is getting too chummy. I want to play devil's advocate. I mean, I think one important value of what you might call the machine learning revolution is its democratizing effect. The fact that the problem is defined in terms of what the data annotations say, right? Data annotations are a definitive show you definitively what is expected in a task. And then there are a number of models that you can apply to those data annotations and get you know, strong performance. And those models are freely shared and easy for people to pick up. Whereas, you know, if you have a rule-based system, it tends to drive you in the direction of having a priesthood. Right, you can get very complicated systems, and a lot of expertise is required to manipulate models that are implemented in terms of rules. Yeah, I'm conflicted about this aspect of it. I don't think it's all, you know, the advantages of rules are entirely clear cut.
Yeah, Dayne, that's an interesting point. I mean, the priesthood of rule-based systems, I think that's possibly valid. On the other hand, putting too much, depending entirely on annotated data is one of the big weaknesses of, you know, machine learning-based systems, because it requires that you have A, agreement on what the task is, B, some notion of what, you know, what the truth is. And both of these things are often not realizable very well in practice.
right? But if you can't define truth, how do you make scientific progress, right? If you don't know what phenomenon you're trying to model, how do you advance?
Right. I often say if humans can't do it and agree on it, then there's no point in having a machine do it because you have no idea whether it's right or not. On the other hand, I think, yeah, it doesn't scale very well. I mean, there are,
Yeah, no, I mean, I think I agree. And I really resonated with what Ellen said in her talk when I got her to rant about F1. I mean, exactly. But it isn't down to the metric. It's more down to less than creative approaches to using the metric, right? So one problem with machine learning, this data annotation of reference problems paradigm is reference problems is all we eventually see. This is all, I've had read papers where they were addressing named entity recognition and they referred to it uniformly as information extraction, right? So for a newbie in the field, they're just not aware of kind of the range of problems that are out there because they're strongly focused on these reference data sets on which that gets you published, basically. But I don't think that's the machine learning paradigm so much, or the F1 metric specifically. It's just not being very creative and not really being very imaginative in your approach to science.
Since Dayne tried to throw some devil's advocacy, I guess I should try to do the same. I don't want us to get too chummy, but I disagree that humans can't agree on truth when it comes to language. I think it's just about the level of abstraction that most humans choose to live at, because we're not all ridiculous linguists who like to study the pedantic syntax of individual sentence structures. I think that at some level of abstraction, I think we can actually largely agree on truth and et cetera. I think it's just, the challenge is that to understand language, you have to get down to these very detailed specifics, and you have to start talking about the spans and the overlapping spans, and that's where humans cease to agree because they don't know what the hell you're talking about. At some level of abstraction, I think we can agree. The problem is how do you connect those levels of abstraction down to the actual detailed level of syntax that you actually need to be able to parse, individual text.
I'm going to take some issue with your notion that we can all agree. If we get abstract enough, that may be true. But if you take, common applications of NLP, like medical record extraction from medical records, we were working for a while on trying to understand whether the medical record showed evidence of antibiotic resistance. You can't get expert, practitioners to agree whether or not the medical record has an unambiguous signal about whether the patient had, there was antibiotic resistance in that record. I mean, it's, you need not only detailed subject matter expertise to create these gold standards, but you need multiple subject matter experts, and you need some notion of the fact that it's not going to be clear. There's going to be disagreement, and our current notion of having a gold standard and measuring ourselves against that, I think is part of the problem in this sort of overemphasis of F measure. And yeah, anyway.
I wanted to jump in here. Oh, sorry. No, please go ahead, Ben.
There's one more point to this discussion, that very often I think experts can agree if they have a specific endpoint in mind, like a specific application in mind. I think it's hard to agree on curation or like annotation without a specific goal in mind. I think that's what causes a lot of disagreement and confusion. So, and that's also an issue with all these F-score based evaluations, is that when annotations were made against which we score a certain set of goals was assumed that may not even be clear and may not fit some other application.
Well, and that's why when we're developing these technologies, and actually one of my favorite parts about using and engaging with this community of rule-based systems is the worst thing you can do in developing a technology is to build the technology and then to figure out what problems it solves. What you first need to do is figure out what your problem is, and then try to find a technology that can actually solve it. And having actually, adaptable and understandable and explainable and et cetera technologies is really good for that, because your problems come up fast and furious and change constantly, and you need to be able to adapt your technology to be able to do the same. But too often than not, in these sorts of discussions or other sessions, we lead with the technology rather than leading with what the actual problem is that we're trying to solve. And we never come to solutions.
Actually, you've set up perfectly how I would like to introduce another topic, or that's sort of been floating in the background, I think. And that is, so yeah, there's a lot of really new shiny hammers. And I think that many of us who are involved in putting together this workshop have had kind of a concern, the fact that we needed to kind of have a special workshop that is highlighting, are rules still a thing? Do we still care about them? Of course, we're here, the choir, are all agreeing, yes, absolutely, this is exceedingly important. So here's a set of questions. First, do we agree that it does feel like that the field is a little bit off course? Number two, how might we get it on course? And as part of that, for those of us who still see the value and necessity of rule-based systems, how do we get along in the age of deep learning? So I'll open that up, can of worms.
So I will start with that one anecdote, because I talk to customers all the time, and I essentially have two kinds of customers. I have the customers who say immediately, oh, does IBM Watson understand transformers? And then I have the other kinds of customers who are essentially seasoned NLP practitioners. And whenever I get the first question, I know I deal with someone who is new in the field and has read a lot of Medium posts. And then whenever I get to the second category, I'm like, okay, yes, I have systems that can help you guys. So definitely in the industry, I have seen a tremendous amount of use cases who simply benefit from hybrid systems. There is a business problem that needs to be solved, and when you look at it, you break it down, and one part of it, it's dictionary matching, and then maybe another part is some sentence classifier that you need to train from label data. But the ability to have a system that supports an array of techniques that can be combined together is exactly what seasoned NLP practitioners are looking for. As to how we will actually make this known in the academia, I will let the folks that work in the academia try to comment on.
So I want to briefly respond to something that Joshua said, because it really resonated with me. I think there is a very big gap sometimes between what we obsess over in our research papers and the way we look at our results and the real world. And evaluation is a really good example of this. So Lynette, you were asking about ways to improve evaluation. I don't have answers here, but I've got thoughts on problems. And one of them is, I think, this issue Joshua's mentioned, where the way we evaluate is very different than the way an end user evaluates. So let's just take, for example, BIO labeling, which is so widely used in information extraction, right? Or some similar type of approach. Our papers will kind of report just the accuracy of the B's and the I's and the O's, not even separating them out sometimes, much less looking at the full span and how close the full span matches to the real answer. And, some spans, a slight overlap is no big deal if you leave off of the terminer. Other times it's catastrophic. But so many people in our field don't even think beyond that. In my class, for example, I have a little exercise where I force them to evaluate at the span level instead of BIO, and it kind of breaks their brain sometimes because really, we live in these very geeky bubbles, and I'm not sure what the answer is to this, except perhaps designing new evaluation metrics that really have the end user in mind. And also there is an industry track that I think was revived for a little while in NACL. I don't know if it exists like this year.
Yeah, it's still there.
But that's a place where I think people who represent the end user community can come and really talk about these issues and raise awareness and maybe start advocating, because there's both kinds of people who attend the conference when there's a healthy industry track there.
Yeah, I actually reviewed for NACL, and I was impressed at how interesting the papers were, because they were talking about end users and they were talking about practical considerations, talking about things like, language drift and how do you deal with that in a fielded system. I mean, so I found it actually fascinating. So I think we need evaluations that are more applied somehow, or look at the whole use case from beginning to end, including gathering annotated data, which is a huge bottleneck. So yeah, anybody who has any ideas, I'd love to hear them.
So I want to, oh, go ahead, Dayne. Oh, okay. All right. So thank you, Ellen, because that just reminded me of something I haven't thought about in a long time, which is a fantasy I had about. So one of the programs I was doing called Causal Exploration of Complex Operational Environments. We were working with a whole bunch of green suit operators, military planners who wanted to use NLP and causal modeling to be able to like extract and surface information that would be useful to them in understanding really complex systems and modeling. And they, initially in the program, we thought, okay, we need to be able to surface and connect all of this information automatically for these people to show it to them. And that's what everybody was trying to do. Let's extract and surface and connect all of this useful information. But that was not actually what these people wanted. What they wanted was people to show them something that surprised them, show them something that interested them, show them something that actually went against what their sort of natural bias in a given system was. And it struck me at the time that when we talk about NLP, we very rarely talk about the psychology of, human knowledge or cognition or whatever it is, of human decision making and things like that. And ultimately, in these cases, at least, we are trying to extract knowledge and present it to people in complex and rich ways that actually will, either support or challenge the kinds of the things that they're trying to figure out in these complex domains. That's what they're trying to do. It's a much more subtle and higher level kind of semantics than I'm trying to understand causation in this environment, right? It's more like I'm trying to figure out what is the thing that I am not thinking about, right? It's a much more internal sort of thinking kind of a thing that I'm not sure if we talk about when we talk about rule-based NLP, or especially in evaluation. And it obviously raises the level of abstraction and is a very difficult thing to even define or explain. But that's something that I think would be just wonderful to be able to do and understand if it was possible.
I just want to highlight something that Gus has been kind of reminding me or pointing out. A lot of the discussion we've had has been about extraction and then maybe evaluating extraction, whereas what I think Josh was now getting into, and this is what's constant, I think, to what Gus has been thinking about, is the problem of using or synthesizing and reasoning over information that is being extracted. And I'm wondering whether or not that kind of perspective, rather than just thinking about evaluating, did you extract, but how is it being used relative to a task? Or, by the way, Gus, jump in if you have a better way of putting it. I feel like I'm a little bit passionate.
No, that's fine, Clay. I mean, as you reminded me that we're almost out of time, unfortunately, and I feel like it's just getting started. So, but basically sort of the role or how we approach synthesis and then reasoning. What do we do with those things? And what is the metric for that? Speaking of F scores or new metrics. So.
I mean, jogging sideways a little bit, your mention of information extraction has been kind of the implicit focus of the discussion. I mean, part of that is down to the fact that you have a bunch of information extraction wonks on the panel, but I think it's also the case that it is among NLP applications particularly amenable to rule-based methods, whereas I'm not sure that extends to a lot of other applications. So, for example, I wanted summarization. How am I going to do a rule-based summarization system that's even going to compete? Even document classification, yeah, you can do rule-based document classification, but is it going to be as robust as a machine learning system? So I think there is a set of tasks for which rule-based methods are particularly applicable, but I don't think it's all tasks that we would consider NLP tasks.
That's actually a very good point, and I think that would be a whole other topic, would be to kind of taxonomize where is it the rule base are most appropriate for task-wise versus, I think it is, while even as you put it, a lot of the people here are extraction wonks, you guys still use statistical methods and also appreciate them and see the value in them. And it's because of these differences in tasks. Well, I have the unenviable task of saying that we've reached the end. This was a really, really cool discussion that I'm very happy that we got to touch on a number of the different topics that we did get to. I'd like to thank the panel. I really appreciate it, especially those who are on the East Coast who have stayed up very late, even some of us on the West Coast. Yeah, this was great, and I would love to keep going, which I think means it was a good, successful panel. So thank you. And I think, there's a 30-minute break now for lunch for those who are local. And then there will be the second session that we'll pick up in the afternoon at 1 p.m. Local time. So again, thank you. Appreciate everybody's contributions.
Thank you all. I wish this was longer.
Yeah,
Thanks,
I know.
I'm really glad I managed to stay awake for this. This was
We
yeah,
appreciate
no,
it. Thank you, and all of them. Thank you.
Thanks,
Thank
everybody.
Bye.
Bye.